Alright, a highway entrance ramp rises 37.25 feet in a horizontal distance of 180 feet. And when it says in that, that means that it's just a ramp. And the length of it is 180 and its height is 37.25. That's all it means. What is the measure of the angle that the ramp makes with the horizontal? Okay. So we've got 180 feet, and then we went up 37. And we want to know what is this angle that we create when we go up 37.25 feet. So we have 180 feet here. Notice there are 2 places after the decimal, so we're going to have 2 places after the decimal with our angle. And then here we've got 37.25. And our angle is here, which we'll just call it x, degrees. Let's find it. Opposite over adjacent, because of course when it makes, that's horizontal and vertical, that's our hypotenuse over here. So the tan of x is equal to opposite 37.25 over 180. Punch it into your handy dandy calculator and solve. We are looking for an angle, and just give me 2 places after it. So second tan 37.25 divided by 180. And our angle is 11.69 degrees. Now again, sometimes the problems in your book ask you to go to the nearest minute. If they do, again, you just do second, apps, 4, enter, and you'll get 11 degrees and 42 minutes. Because round it to the nearest minute. When you have a little extra, you just round it on up. 11 degrees, 42 minutes. Alright, let's do a nice but different type of picture. This is the type of picture where you have to draw extra auxiliary lines to help you solve the problem. This is a plot of land, because most land isn't perfectly rectangular. We've got to compute the distance AB, which is this is from here to here, as well as the distance BC from there to there. And we need all of these lengths, and I do mean all of them. So the first thing we're going to do is we're going to draw a line straight down right here. This line is going to be very important because we need it to figure out BC as well as AB. And we can name it or not. It really doesn't matter, as long as we draw it straight down and it creates a right angle. So let's take our little triangle that we just created. Ooh, don't let me draw it. See if I can find something to help me make a straight line. Okay? This is our little triangle that we're going to draw. Okay? And okay. Alright, so we've made a right angle here. And this is A. And this is B. Now, how long is this side right here? Well, this whole side is 105, and this little length is 60. So to figure out this length right here, we do 105 minus 60. So let's do it. 105 minus 60, I'm hoping it's 45. Just doing mental math. It is. So that means this length from here to here is 45. And we know that this inside angle is 33. Now, if I want to find, make that look a little better, my goodness. My handwriting doesn't have to be that bad. Alright, so that's 33 degrees. And since the first thing I want to find is AB, I'll go ahead and put a little X right there so I can find it. So the angle, the side adjacent to it, and we're looking for the hypotenuse. So the cosine is in order here. The cosine of 33 degrees is going to equal 45 over x. Again, you can create a proportion, put a 1 underneath your trig function, cross multiply, or you could just do x is equal to this divided by that, and that's what I'm going to do in the calculator. So, in the calculator we put 45 divided by the cosine of 33. And we end up with 53 53.66. Why do I go to two places? Because there's two places in each of the sides in the problem, and I use the problem as my guide. So 53.66 is AB. I'll replace that with AB so I know I found it. And we'll put meters on the end. Alright, now let's find BC. In order to find BC though, we need to find out what this side right here is so that we can subtract it from this long side right here. And the way that we find y, that's the side that's opposite from 33 over the 45, is to use the tangent. Or you could use the sine, because you now know the hypotenuse is 53.66, but I'm going to just use the tan. The tan of 33 is equal to y over 45. And like I said, you can add auxiliary letters. If you don't like x and y, put your initials in there. It doesn't matter. Okay, so let's calculate. 45 times the tan of 33. 29.22. That's good to know. Make sure that's right. 29.22. That's this little length right here, this purple length. If I want to find BC, all I have to do is do 82 minus 29.22. And I'll go ahead and use what's in my handy dandy calculator and say minus 82. And I'll get 52.78. And that's the length of BC. $52.78. And that's all it is to do in that picture. So this is AB in meters, and this is BC in meters. It's not too bad, but it is a lot to get used to, knowing that you can draw extra lines. You can create right triangles on any shape if it will help you find the length. Alright, so let's compute the distance across, in centimeters, of two consecutive holes in this base plate. And what they tell us is that each of these holes are equally spaced. So that means that these arcs are equal to each other, which is why we dealt with circles before we did this section. Anyway, one circle is 360 degrees. So that means that each of these arcs is 120 degrees. And that's helpful. But we can kind of maybe connect these two, because that's the length that they really want us to figure out. How long is it from there to there? And we can kind of go from the center and know that this central angle is going to be 120 degrees, because if you've got this arc and you've got that angle, central angles equal their intercepted arc right there. You know? So this is 120 degrees. So if I draw an altitude straight up and make myself a right triangle, I have a 60-degree angle right here and a 60-degree angle right there. It's quite lovely. So let me draw this triangle a little bigger so we kind of know what we're looking at. Okay, so again, this angle right here is 60. This is my right angle. Now let's talk about our length. They told us that the diameter is 4.36. So using our calculator, 4.36 divided by 2 will be our radius, which is 2.18. This side is a radius, and so is this side. So that means this hypotenuse is 2.18. And what we need to find is this side right here, which is the same length as this side right here. Because when you bisect this triangle happens to be an isosceles triangle, because those two sides are equal. That altitude cuts it into two equal right triangles. So if this side is x, so is that side right there. And we can figure out this whole length x by doubling those little values. I think I should pick a different letter other than x, since that's what they used in the problem. So I'll pick n instead. And if we double n, we'll get what we're looking for. Let's put an n right there. Alright, so what trig function should we use? I hope you said the sine. Opposite over hypotenuse. So the sine of 60 is equal to n over 2.18. And then when we solve this problem, 2.18 times the sine of 60, we find out that that length is 1.89. Or let's go 3 places after that, 1.888. And then when we double it, because there's 2 of them, we find out the length that we're looking for is 3.776. So x is equal to 3.776 inches. And that's all. Good luck.